Hello everyone, welcome again to this video segment. In this segment we shall talk about the solution of linear equations, and we shall mainly focus on fractional equations with fractions. Okay, we have 5 problems. Let's start with number 1. Negative 7 over 8q equal to 6. So in this case, where you have a fraction, the easiest thing to do is to find the least common denominator, and then you multiply both sides of the fraction. That is the left hand side and the right hand side. You multiply both sides with the least common denominator so that you can eliminate the fraction. And once you do that, you get back solving the whole number equations. Okay, so in this case, this simply means I will do this example 1 with 2 methods, or I will do it in 2 ways. So whichever way you feel like learning, that's fine. But for the rest of the problems, I will just do it with just one way. Yeah. So the way I will recommend is the one I just talked about, finding the least common denominator and multiplying the both sides of the equation, that is the left hand side and the right hand side, by the least common denominator. So actually we have this fraction, this means 6 over 1. Anytime you see this, it means 6 over 1. So you ask yourself, what is the LCD? What's the least common denominator of 8 and 1? It gives us 8. Please, you need to review video segment on factors and multiples so that you can follow up on this, and also on linear equations too, but integers only. You need to view those segments. You should also view the segments on distributive property. You need the knowledge so that you can understand this. So I'll just say multiply both sides by the least common denominator. Multiply both sides by 8. Okay, so we now have that 8 will multiply negative 7q over 8 equal to 8 will multiply 6 over 1. Of course, 8 will cross out 8, so we have negative 7q equal to 8 times 6 is 48. So when we now have this, we see that q, we now divide both sides by negative 7. We now divide both sides by negative 7. And that gives us that q will be negative 48 over 7. Some people might ask, why is it not negative 7 over 48? I said this earlier on. We like putting the negative as the numerator on top, because positive divided by negative, this is positive 48, this is negative 7. Positive divided by negative will give us a negative. We just put the negative on top. So this gives us q. And then we can check this. We can check this. Of course, we write the original equation, the main equation, and then we have our left hand side and our right hand side. For the left hand side is negative 7 over 8q. Right hand side is 6. So all we need to do is we substitute for q into this equation, into this expression. So this gives us negative 7 over 8 times negative 48 over 7. As you can see, when we did multiplying fractions, this will cross out, and then 8 will cross out 8. 8 will cancel 48, 6. So this is negative 1 times negative 6, and that gives you 6. 6, 6. And there you go. You have it that way. Now, if you want to convert this to a mixed number, that's up to you. But I would say leave it this way, so you could easily check it with that. Now, that is one way. The second way, the second method, or the second way, is you can use the cross product, cross multiply. Okay, when you have negative 7q over 8 equal to 6 over 1. In this case, you can use cross multiply. Cross multiply. And cross multiply means it goes this way. It goes like this. You multiply the numerator of the fraction on the left hand side with the denominator of the fraction on the right hand side. Similarly, you multiply the numerator of the fraction on the right hand side with the denominator of the fraction of the left hand side. So you have something that looks like a x across, x across. Some people call it the butterfly method. So because it looks like a butterfly. So this is negative 7q times 1 equal to 8 times 6. And that is negative 7q will give us 48. And then you divide both sides by negative 7. Q will be negative 48 over 7. Okay, let me compare these two methods. I would prefer this method over this one. Though some people might say that this is easier for them. Let me tell you why. There are this question, we only have one entity or one term, right, on the left hand side and one term on the right hand side. If you have it that way, good, you can use cross product or cross multiply. You can do it. If you have just a single term on the left hand side and a single term on the right hand side. Now, but when you have two or more terms on any of them, either the left or the right, you can't just go straight and use cross product. You have to make sure that you make the two or more terms that you have on the left or on the right, you have to make it a single term. You have to make sure that you have only one term on the left and one term on the right. I will show you an example. Let's do number 2. Let's do number 2. Okay, number 2 says 2 over 3j plus 8 equal to 1 over 4j. Now, if you look, you have two terms on the left. You no longer have a single term on the left and a single term on the right. You have two terms on the left. So you cannot use cross product or cross multiply on this question because, well, you cannot use it directly on this question. You have to first of all combine it to a single term on the left before you can now use the cross multiply. So, you don't want to do that. I mean, if you want to do that, that's fine. But I'll just go ahead with the first method. Okay. Now, if you look, the denominator here is 3. The denominator here is 1. The denominator here is 4. So what is the LCD in this case? The LCD here is 3, is 12. 3 times 4, which is 12. So I want you to review your LCD video. Okay, so we have to multiply 12 by both sides. So this is 12 into 2 over 3j plus 8 equal to 12 times 1 over 4j. Right? So in this case, when we distribute, we have 12 times 2 over 3j plus 12 times 8 equal to 12 times 1 over 4j. Of course, this 3 will cross out. 4 times 2 is 8j plus 96 equal to 3j. So you see, we've now made sure that these fractions, the equivalent of this fraction to whole number is this expression. Then we can now do it 8j minus 3j equal to negative 96. Just like we did on integers only. You need to view the video. So we now have here that this is 5j equal to negative 96. And j will be negative 96 over 5. Yeah. I know I said I don't want to use the cross multiply, but let me just show it just with this question again. With cross multiply for this question, if you want to use cross multiply for this question, we need to, first of all, let's put the variables on the left, constant on the right. So 2 over 3j minus 1 over 4j equal to negative 8. That is the first thing. So now we subtract this fraction. You need to view subtraction of fraction. LCD of this is 12, of course. So we have 12j. This will be 8j minus 3j equal to negative 8. If you do the fraction, you see what I'm talking about. So you have now 5j over 12 equal to negative 8. And in this case, you can now do the cross product. 5j times 1 equal to 12 times 8. So 5j to be equal to 12 times negative 8, I mean. So this is negative 96, and then j will be negative 96 over 5. So you see, when you do the cross product, when you have just a single term here and a single term there, yeah, that's when you do this. So whichever way you prefer, but I will be using this way. I'll be using this way. All right, let's check this question before we go to the next one. In the check, we write the original question as usual, 1 over 4j. Then we write the left-hand side, right-hand side. Left-hand side is 2 over 3j plus 8. Right-hand side is 1 over 4j. So, and our j is negative 96 over 5. So this is 2 over 3 times negative 96 over 5 plus 8. So, I guess we can cross out. 3 into here will be 1. 3 into here will be 32. And that is negative 64 over 5 plus 8. Of course, if you do this fraction, negative 64 over 5 plus 40 over 5, which is negative 104 over 5. Some people will ask me, how did I do this? Just, if you don't know, 40 divided by 8, 5 is 8. So I wanted to make sure that they have the same denominator. This is negative 64 plus 40. I'm sorry. This will give you owe 64, you have 40. This will give you negative 24 over 5. Yeah. So, but if you don't want to do this, you can still do this as negative 64 over 5 plus 8 over 1. And the LCD is 5, and then you work it out like that. Just view the videos on the addition and subtraction of fraction. But this is what it will give you, negative 24 over 5. And then here, 1 over 4 times negative 96 over 5. So 4 will cross out, 4 will cross out, 4 into 9 is 2, times 4, 8, 16, 4. So this is negative 24 over 5 as well. So 4 divided 96 gives you 24. 4 divided negative 96 gives you negative 24. So our left hand side and our right hand side, they are equal. We are good. Now, let's go to question 3. And I'll be working only one method from now. I'll just use one method. 3, we have 2a plus 1 over 3 minus a minus 1 over 4 equal to 0. Now you have to be careful because of this negative here. And we shall apply some distributive property. Now what's the LCD here? LCD here is 12. So we multiply 12 into 2a plus 1 over 3 minus a minus 1 over 4 equal to 12 times 0. So this is 12 into 2a plus 1 over 3. Then minus distribute 12 into a minus 1 over 4 equal to 0. 12 times 0 is 0. So 3 will cross out 12. This is 4. So this is 4 into 2a plus 1 minus 4 will cross out 12, which is 3, minus 3 into a minus 1 equal to 0. Now if you have this, you apply the distributive property, just like we did on that initial video. So this is 8a plus 4 minus 3a plus 3 equal to 0. Right? So move the constants to the left hand, to the right hand. If you move them, this is negative 4, negative 3. So 8a minus 3a is 5a equal to negative 7, right? So a will be negative 7 over 5. And then we check our work. We check our work to make sure that it is correct. In check, we write the main problem, 2a plus 1 over 3 minus a minus 1 over 4 equal to 0. Left hand side is 2a plus 1 over 3 minus a minus 1 over 4. Right hand side is 0. Okay, so we substitute that for a. 2 times negative 7 over 5 plus 1 over 3 minus negative 7 over 5 minus 1 over 4. Okay, this gives us negative 14 over 5 plus 1 over 3 minus negative 7 over 5 minus 1 over 4. So this gives us negative 14 over 5 plus 5 over 5 over 3 minus negative 7 over 5 minus 5 over 5 over 4. Okay, I'm still working it out to make sure that it will give me 0, which is the right hand side. So negative 14 plus 5 gives us negative 9 over 5, right, over 3 minus negative 12 over 5 over 4. So this actually tells you this is negative 9 over 5 divided by 3 over 1 minus negative 12 over 5 divided by 4 over 1. Remember what you do in division. Negative 9 over 5 times 1 over 3. Negative 12 over 5 times 1 over 4. 3 will cross out. 3 will divide 9, gives you 3. So this is negative 3 over 5 minus 4 will cross out. 4 will divide negative 12, gives you negative 3. Okay, this is negative 3 over 5. Let me explain this again. 3 divide negative 9 gives you negative 3. Negative 3 times 1 is negative 3. Then 5 times 1 is 5. Because 3 divide 3 is 1. Okay. The same thing here. 4 divide negative 12 gives you negative 3. 4 divide 4 is 1. Negative 3 times 1 is negative 3. 5 times 1 is 5. So when you see two negatives, two signs close together, make it one sign. This is negative 3 over 5 plus 3 over 5. And that gives you 0. 0 on the left, 0 on the right. You're good. 0 on the left, 0 on the right. You drink soda. You're good. Okay, number 4. We have 2k plus 5 over 5 equal to 3k plus 1 over 2 plus negative k plus 7 over 2. The same thing is what we do here. The same thing is what we do here. We find the LCD and use it to clear the fractions. So what's the LCD here? LCD here will give us what? 10. So we use 10 to multiply. 10 into 2k plus 5 over 5 equal to 10 into 3k plus 1 over 2 plus negative k plus 7 over 2. Okay, let's begin. 5 will divide 5, 1. 5 divide 10 is 2. So this is 2 into 2k plus 5 equal to, distribute this. This is 10 into 3k plus 1 over 2. Now, plus 10 into negative k plus 7 over 2. Now, we bring down the sign just as we did in distributive property. Okay, so this is 2. If you distribute this, this is 4k plus 10 equal to 2 divide 2, 1, 2 divide 10, 5. 5 into 3k plus 1 plus 2 divide 2, 1, 2 divide 10, 5. 5 into negative k plus 7. Right? So this is 4k plus 10 equal to, distribute, 15k plus 5 plus negative 5k plus 35. Right? So this is 4k plus 10 equal to 15k plus 5 plus minus. When you see two signs together, make it one sign. Minus 5k plus 35. Okay, so get the variables one side, get the constants one side. So this is 4k minus 15k come over here is minus 15k. Negative 5k over here is plus 5k equal to, who is here already? 5 is here already. 35 is here already. Move 10 to join the right hand, negative 10. So 4k minus 15k gives you negative 11k plus 5k equal to 5 plus 35 is 45. Is 40. 5 plus 35 is 40. 40 minus 10. So negative 11k plus 5k gives you what? Negative 6k. Negative 6k equal to 30. 40 minus 10 is 30. So this implies, this tells you that k will be negative 5. You divide both sides by negative 6 and k is negative 5. Okay, but we don't stop here. We've got to make sure that what we got is correct. Otherwise, we will have to redo it. We'll have to redo it. In checking, we write the main problem, 2k plus 5 over 5 equal to 3k plus 1 over 2 plus negative k plus 7 over 2. Left hand side, right hand side. Left hand side is what? 2k plus 5 over 5. Right hand side is what? 3k plus 1 over 2 plus negative k plus 7 over 2. Now k is negative 5, so we substitute, we plug it in. So this is 2 times negative 5 plus 5 over 5. Let's finish with this one real fast. So this is negative 10 plus 5 over 5. So this is negative 5 over 5. This is negative 1. Left hand side give us negative 1. Let's do the right hand side. 3 times negative 5 plus 1 over 2 plus negative 5 plus 7 over 2. That gives us negative 15 plus 1 over 2 plus 5 plus 7 over 2. Negative times negative is positive. Two signs together make it one sign. So this is now negative 14 over 2 plus 12 over 2. This is negative 7 plus 6. And this is negative 1. Negative 1 on the left, negative 1 on the right. You drink some soda. That shows you got it. And then you can start jumping. Okay, the last one, number 5. C over 3 plus 7 equal to 5c over 6 minus 2 minus c over 2 plus 9. Now you look at this now. Don't be scared of all these fractions. It's nothing. Just apply the same rule. Variables on the left, constants on the right. So let's get all the c's. C over 3, this guy comes over here, minus 5c over 6. This guy comes over here, plus c over 2. Equal to, this guy is here already, negative 2, keep it. Plus 9 is here already, keep it, plus 9. This guy moves over there, minus 7. That's it. Okay. Now, but some people might say, I'm not following the steps again. You can, if you want to use cross product, then you start with this step. But if you don't want to use cross product, which I don't, I'll go back here the denominator is 3. Here the denominator is 1. Here the denominator is 6. Because this means 7 over 1. That is what it means. So this is 3, 1, 6, 1, 6, 1. What is the LCD of 3, 1, 6, 1, 2, 1? The LCD is 6. So let's multiply everything by 6. All of them. 6 times C over 3 plus 7 equal to 6 times 5C over 6 minus 2 minus C over 2 plus 9. We can do that. But if you want to use cross products, then that is when you start with arranging it. Yeah. So this will be 6 times C over 3 plus 6 times 7 equal to 6 times 5C over 6 minus 6 times 2 minus 6 times C over 2 plus 6 times 9. So this gives 3 will cross out, 3 into 3, 1, 3 into 6, 2, 2C plus 42 equal to 6 crosses out 1, 6 crosses out 1, 5C minus 12, 2 crosses out 1, 2 crosses 6 is 3, minus 3C plus 6 times 9 is 54. Right? So we can now get everybody. Variables on the left, constants on the right. So this is 2C minus 5C plus 3C equal to negative 12 plus 54 minus 42. So you see now, 2C minus 5C gives us what? Negative 3C plus 3C equal to negative 12 plus 54 gives us what? Gives us what? 42 minus 42. So we see that 0 is equal to 0. Right? So this is what we call infinite solutions. Infinite solutions. We talked about this in the equations, on introduction to equations. So we don't need to check this. This gives us infinite solutions. 0 is equal to 0. And we know the type of equation it is. We talked about this in the equations 1. It gives us infinite number of solutions. All right. Thank you for listening to this video segment. And if you have questions, please go ahead and write your questions on my website, or just make the comment on the YouTube page and I will attend to it. Thank you so much for listening. On the moment of conscience, I would want to thank everyone and encourage everyone to do well this semester. Mathematics is not difficult, just work your best, and I'm here to help, okay? All right, you have a nice day, and bye. See you again.